Okay, today's lesson is going to be proportions with similar triangles. So let's give the do now a try. Okay, so real quick in the do now, they were asking you which student wrote a statement that is not true. So if you look at Chelsea, she's saying that angles 1 and 2 add together to give you angle 6. Now angle 6 is that exterior angle, and the two remote interior angles from angle 6 are 1 and 2. So they really should add to equal angle 6. If you look at what Bobby said, his exterior angle is angle 5, and he's saying that that's equal to angle 1 plus angle 3, which are also remote exterior angles to angle 5. So that is also true. If you look at what Katie is saying, she has that angle 3 is equal to 1 plus 2, but angle 3 is an interior angle, and so is angle 1 and angle 2. So Katie is therefore incorrect. It should say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And then just to solidify, if we look at Mark's looking at this exterior angle, angle 4, and angle 2 and angle 3 are those interior remote. As I'll erase that and kind of say that clearer. So the two angles for Mark from angle 4, which is the exterior angle, are angle 2 and angle 3, which are the remote interior angles, because those are those interior angles across the way. So it is true that angle 2 plus angle 3 should equal angle 4. Okay, now moving down to a topic that is probably somewhat familiar to you is solving proportions. I'm going to remind you that when you look at your proportions here, that you're going to cross multiply. Anytime you have a fraction equal to a fraction, your cross products are equal. So 2 times x would equal 2x, and I'm going to set that equal to 1 times 8, which would be 8. From there, very easily you're able to solve that proportion and get that x was equal to 4. And again, just a nice little thing you could do is you can do a quick check. That 1/2 is equal to, I'm going to replace the x with the 4, and it is equal to 4 over 8. 4 over 8 does reduce down to 1/2. So you still can do your check to make sure that your answers make sense. All right, if we come over to the second one, you can give this one a try. Okay, hopefully you agree. X is equal to 18. Right? And number 3 is just it's a little different, but it's much nicer. You're doing 1 times x plus 5, which really is just x plus 5. And then 2 times x is 2x. Just be careful in solving. You want to make sure you realize you have 2 terms that contain your x's. So therefore you want to bring them together. I don't like to get 0, so therefore I'm going to subtract x from the left side and also from the right side. Bring down my 5. And remember, that's 2x minus 1x, which is just 1x. And if 1x equals 5, then x is equal to 5. Same as x is equal to 5. All right, and those are your proportions from what you probably remember learning in 6th or 7th grade. Okay, for this bottom piece, this is the new part that I'm going to introduce to you, is that now when you go to do your cross products, all right, this part is fine. 15 times x is going to give you 15x. But now when you go this way, what property do you think we're going to use? And if you guessed, it is the distributive property. You have to remember you're doing 5 times x plus 8. And from there, you want to remember that you are going to distribute. And therefore, you are going to get 15x is equal to 5x plus 40. And then you're going into solving and realizing you have 2 x terms on opposite sides rather. So you're going to use the opposite operation. I'm going to subtract 5x. 5x minus 5x cancels out, and therefore 10x is equal to 40, and you're dividing by 10 to get x is 4. And that's the basic concept that you're going to get when you're doing these proportions now, is that moment where you're going to use your distributive property. Okay, you could try number 8. Oh, sorry, a little error there. This should be 40 when you divide by 40. Okay, and then number 9. And you're going to distribute. Okay, for the second part of our lesson, we're going to talk about similar triangles and our proportions. Okay, we understand that similar triangles, so the word similar, the main idea of it is that you have the same shape, but not necessarily the same size. All right, if you're congruent, you are the same shape and the same size. If you are similar, you are just guaranteed to be the same shape, but not necessarily the same size. All right. Another thing that we talked about in class is that if you have two similar triangles, the corresponding angles are congruent to each other. Okay. The length of the sides are considered proportional, but the angle measurements aren't going to change. So if you look at this picture down here, these two triangles are similar. They're the same shape. They're not the same size, but their corresponding angles are congruent. Angle A is 30 degrees, so is angle R. Angle B is 100 degrees, so is angle S. And angle C is 50 degrees, and so is angle T. So you can change the size of a triangle, and it doesn't change the angle measurements. And that's and then what comes out of that is that you have your proportional sides when you have similar triangles. So your sides are in proportion. And therefore, you can use that information in order to find a missing measurement. So if we just go through over here, you're filling in what your corresponding angles are. So if I look at those two triangles, the angle that corresponds to A, right? A is up here. So therefore, it's angle R. What corresponds to B is going to be angle S. And what corresponds to C is going to be angle T. So those are your corresponding angles. You also have corresponding sides. Geometry gets a little picky. If you're looking at side AB, right? So that means you're coming from A down to, down this way, down to B. That means its corresponding side, you're going to start at R and you're going to go down to S. So that's going to be side RS. If you look at side BC, I'll change my color. So side from B to C is going to be side S to T. And therefore, side C to A is going to be side T to R. Those are corresponding. And then once you look at, if I could just kind of erase all of this in here and just kind of look at our two similar triangles, right? Remember, we talked about on Friday that since these corresponding angles are all congruent to each other, that is telling us that we have similar triangles. And when we have similar triangles, our sides are proportional. Now, 20 is the length of one of the sides, as well as 10. And then 6 is the length of one of the sides, and X is representing the length of the sides. So if I can just put like these little slashes on the actual triangles themselves, you can see our proportion. 20 over 6, that can set up my first fraction, has to be equal to my 10 over my X. Okay, it's not the only good proportion that you can set up. You could also have done that 20 is to 10 as 6 is to X. And if you did that one, that means you did the 20 is to the 10, that left side of the triangle is to the base of the triangle, 6 over X. Okay, another good proportion that you could have had is any of these upside down. The way you know that your proportions are similar or the same as at each other is you really do have these cross products that are equal to each other. So you can see that for either of these two. When I go to solve them, I am going to do 20 times X over here, which is going to give me 20X, is equal to 6 times 10, which is going to give me 60. And then I'm just going to divide by 20, and X would equal 3. And this same result would come from my other proportion. So even though there's more than one good proportion for every set of similar triangles, as long as our cross products are the same and we get the same value of X, you know that you did a great job. Okay, let's try example number 1. Example number 1 is an example of indirect measurements where they're talking about a shadow, right? So you have a flagpole over here and you have its shadow that's casted on the ground. And then they have this nearby lamppost. They're calling it a lamppost over here. And it too has a shadow casted on the ground. And therefore it's going to create these similar triangles. And you would call this an indirect measurement. But again, right from there, I could put the slash right onto my triangles, and my proportion's going to be okay. And then you're going to do your cross products. And there you have it. Okay. All right. Let's go on to example 2. Again, so looking at the way this is written, it's telling you in the diagram, remember that this little tilde symbol, that stands for similar. If you want to be able to write with your symbols, then you have to be able to interpret them. So you want to make sure you understand. So triangle ABC is similar to triangle QRS. And when we say the triangles are similar, again, it means that the sides are proportional. So I can set up a proportion in order to solve for my X value. Again, I like to do the slashes right between. I see my side 4 and my X plus 6 and my side 3 and my X plus 2. And I kind of set up my proportions just by putting those slashes in. So 4 over X plus 6 is going to equal, remember I did the 4 over the X plus 6, so you want to just be aware of that. If you do 4 over X plus 6, then you have to do 3 over X plus 2. You want to make sure you're consistent. I did the side over the slant is equal to the side over the slant. And that way you make sure you have a good proportion. Once you do, you're going to do your cross products. So therefore, I know that 4 times my X plus 2 is going to be equal to 3 times X plus 6. And then you're going to solve. okay? Okay, and then last but not least, another kind of indirect measurement. If you look at example 3, I'm going to read this. It says, Katerina's boat has come untied and is floating away on the lake. So down here is your lake. Her boat is floating away. She is standing at the top of a cliff, right? So this is Katerina herself, is standing at the top of the cliff that is 35 feet above the water. If she stands 10 feet from the edge of the cliff, she can visually align her vision. So her vision taps here, and she's able to look at the tail end of the boat. So she's looking at the back of her boat. Her eye level is 5.5 feet above the ground. That's her height over here. And approximately how far from the cliff is her boat. So if you look, you can see that they're actually forming these two similar triangles over here. This is the value that we're looking for, which is how far her boat is. So again, I'm going to come in and I'm going to put in my slashes for my similar triangles, and therefore I know 5.5 over 10. So I'm doing her height versus her distance on the ground is equal to the height of this triangle, 35, over the distance from the ground that we're trying to find. Now notice with this question, it does say approximately. That's a nice question to notice, especially because when we start to cross multiply for this question, it's not gonna work out so perfectly. We're gonna get 5.5x is equal to 350. And when we divide by the 5.5, we're gonna get that x is equal to 63.63 repeating. So it says approximately how far. So I'm going to say approximately 64 feet away. Okay, and in my mind, I'm saying, oh, if this was 35 feet, this distance here, it makes sense to me that this would be approximately 64. It looks longer, and it is longer, but it's not longer by a tremendous amount, okay? So you want to make sure your answers are also in the ballpark and make sense. All right, good job. Okay, question A, 2, 3 over 12 is equal to x plus 2 over 18. Cross multiply, don't forget to distribute. 12x plus 24 equals 3 times 18, which is 54. Okay, so x is equal to 2.5. For letter D, same thing, cross multiplying, don't forget to distribute. So you're going to do 5 times your 3x plus 3 is equal to 3 times your 7x minus 1. Don't forget to distribute. And then don't forget again, you have x terms on both sides. So I'm going to choose to minus my 15x. X equals 3. Or C, 9x equals 10 times x minus 3. Distribute. 9x equals 10x minus 30. Don't forget, you have x terms on both sides. So as you go through, I don't want to minus 9x because I don't want to make 0 on the left side. So I'm going to subtract the 10x. I'll get negative 1x over here. This is going to cancel equals negative 30. Be careful. And then when you divide by that negative 1, you're going to get x is equal to positive 30. For number 2, you have these indirect measurements where you have Nina. And again, you could draw your slashes right on your triangles. And you have your 1.2 over 0.9 is equal to x over 240. And when I do cross products, you get 0.9x is equal to 1.2 times 240, which is 288 divided by 0.9. X equals 320. Okay, letter F, we want to be careful. We do have to read here. It says, Julia wanted to measure the height of her school's flagpole. So there's her flagpole. She placed a mirror. So this is her mirror that's on the ground and D1 feet from the flagpole. So they're giving you this D1 measurement. And then she walked backwards until she was able to see the top of the pole in the mirror. So this is going to be Julia herself. And then this is her D2 measurement that she backed up. Her eyes are 5 feet above the ground. So that 5 is her height. And she was D2 feet from the mirror. Using similar triangles, find the height of the flagpole, which is the unknown. If this D1, see D1 measurement is 42 feet, and if the D2 measurement over here was 8 feet. All right, so that a whole lot of talk for us just really setting up our proportions. Now be careful because our triangles are kind of flip-flopped. So I have the height of the flagpole, which is unknown, over this distance for the flagpole, which was 42. And I'm setting it equal to the height of Julia over her distance from the mirror, which is 8. So I'm doing height over distance to the mirror is equal to height over distance to the mirror. So you're just looking for that consistency in the proportion. Cross multiply, 8x is equal to 5 times 42 is going to be 210. You're dividing by 8. And when you divide by 8, you get 26.25. They are telling us to round our answer to the nearest hundredth. And remember, this is your 10th place and your 100th place. So technically, it is exactly the 26.25 because that's what the answer came out to be. If you In letter E, this is that shadow question. So again, right here on the picture, you can put your slashes and read your height over your shadow for, in this case, for, I guess it's just a man, and then you have, I guess, his son. So you're going to do the height of the man, the 52.8, over his shadow, 68.8. is equal to the height of the boy, which is our unknown value, over his shadow, which is 43 inches. And then I'm going to do my cross products. Is equal to 43 times 52.8 is 2,270.4. And when, I lost my X. Let me squeeze that in, 68.8. On both sides, you're going to get that X is equal to 33. And again, my 33 does make sense. The height of the boy should be a little bit shorter than his shadow, only because the height of the man is shorter than his shadow. So 33 inches makes sense for being the height of the boy. In letter E, this is that shadow question. So again, right here on the picture, you can put your slashes and read your height over your shadow for, in this case, for, I guess it's just a man, and then you have, I guess, his son. So you're going to do the height of the man, the 52.8, over his shadow, 68.8. is equal to the height of the boy, which is our unknown value, over his shadow, which is 43 inches. And then I'm going to do my cross products. Is equal to 43 times 52.8 is 2,270.4. And when, I lost my X. Let me squeeze that in, 68.8. On both sides, you're going to get that X is equal to 33. And again, my 33 does make sense. The height of the boy should be a little bit shorter than his shadow, only because the height of the man is shorter than his shadow. So 33 inches makes sense for being the height of the boy. If you did the entire scavenger hunt in order, you would have gotten A, D, C, B, F, and E. All right, good job.